Welcome to today's lesson. In today's lesson, our focus will be on swords, but there are rules for sword. Let's look at the rules. Number one rule, we have when you multiply into terms like m and n, it is possible for you to separate them so that you have square root m times root n. The same to rule number two, if you have square root m divide n, you can separate them to be square root m divide square root n. Okay, at this point, let's simplify some sort using these rules. Number one, if I have this question, root 45, and the question says I should simplify. Now, what I do or what I would do is to look for two numbers that are factors of 45. And of those two numbers, one of them must be a perfect square. The two numbers are 9 times 5. See, the perfect square here, it's 9. You can separate them, and so you have this. So here, square root of 9, 3, root 5. That is the answer to the question. Let's try another one. If I have root 162, again, I'm not going to look for two factors of 162. One of them must be a perfect square. And if you think of two numbers, that one of them is a perfect square, and when you multiply, it will give you 162. It's 81 times 2. And then you separate them. That's the rule of the sword. The square root of 81 is 9 root 2. That is the answer to the question. What about if you have this? Number 3. You have square root x squared y. Now, what do you do here? The same thing. Here, you can separate them into their different square root symbol. So here, the square roots can cancel the square. So you're left with x and root y. That's all. Very easy, right? Let's try out number 4. I have 2 root 50. Now this is also very easy. You look for two factors of 50 so that when you multiply, so that one of them is a perfect square, and that's 25 times 2. And this will be 2 times square root 25 is 5 root 2. 2 times 5, 10 root 2. That is the answer to the question. Now, let's look at addition and subtraction of sorts. Now, number one question, we have to simplify 3 root 5 plus root 45. Now, how do I solve this question? Again, it's very easy. This is 3 root 5 plus. Now, the square root of 45, you're going to look for two numbers. One will be a perfect square, and both will be factors of 45. And that's 9 times 5. So this is 3 root 5 plus, you can separate them, 9 times root 5. And so this will be 3 root 5 plus square root of 9, 3 root 5. Now there's something you must understand here. Subsequently, I will have to be jumping this particular step. Once I get to the step, I will just take the square root of 9 and then put the root sign on the 5. Whatever you decide to do in getting those two factors of the sword, 4 to 5, so that one of them is a perfect square, ensure that at the end of the day, all the terms have the same value here. Root 5, root 5. That's way it becomes easier for you to add them. 3 root 5 plus 3 root 5, and that is 6 root 5. And that is the answer to the question. Now let's look at number 2. 17 root 2 minus 3 root 32. Now, at this point, this is the least you can reduce the sort to, which is root 2. But here, I'm going to reduce this to, or look for the two factors of 32 so that one of them should be 2. And that becomes 16 times 2. Again, apart from ensuring that they are the same, root 2, you also make sure this number is a perfect square. Of course it is. And so this is 17 root 2 minus 3 times square root 16, 4 root 2, which is 17 root 2 minus 3 times 4, 12 root 2. And that gives you 17 minus 12, it's 5 root 2. Now, it's possible for you to subtract them because this is root 2, this is root 2. So 17 minus 12, it's 5. This is the answer to the question. Now, let's look at number 3. Same procedure. This will be 3, 25 times 2 minus 5, 16 times 2 plus 4, 4 times 2. So it's very easy. So this is 3 times square root 25 is 5 root 2 minus 5 times square root of 16 is 4 root 2 plus 4 square root of 4 is 2 root 2. So this is 15 root 2 minus 20 root 2 plus 8 root 2. So at this point, for me, I would want to collect like terms so that I don't make mistake in my subtraction and addition. This is plus 8 root 2, so take it close to this. This is minus 20 root 2, and then you keep it this way. By doing this, you can be able to subtract without using calculator to get the actual value without making a mistake. In my previous video, I've shown how to simplify operations involving addition and subtraction, so you can check it out. Your final answer is 3 root 2. Easy peasy, right? Now let this be the last one, number 4. Now here I have 5 root 18 minus 3 root 72 plus 4 root 50. Again, it's the same thing I'm going to do. This is 5, 9 times 2 minus 3. Now you think 36 times 2 plus 4, 25 times 2. So this is 5 times root 9, 3 root 2, 3 times root 36, 6 root 2, plus 4 root 25, 5, then your root 2. So this is 15 root 2 minus 18 root 2 plus 20 root 2. Now take note, you do the addition first before the subtraction. So 15 root 2 plus 20 root 2. That's 35 root 2. And 35 root 2 minus 18 root 2 should give you 17 root 2. That is the answer to the question. Now let's look at multiplication and division of surds. The first question, I'm to expand 2 root 5 all raised to power 2. Now at this point, you have to be very careful. Everything in the bracket is raised to power 2. So that includes the 2. So it's going to be 2 raised to power 2 root 5 raised to power 2. So this is 2 times 2, 4. And then this will cancel this and becomes 5. This cancels this. So 4 times 5, that gives you 20. There's another way to solve it though, but this method is easy. If you don't want to do this, what you simply do here is to say 2 times 2 times root 5 times root 5. So you see, because root 5 is squared. 2 times 2, 4. And this is root 5 times root 5 is 25. Root 25. So which is 4 times root 25, it's 5. And 4 times 5 will give you the same answer. So, like I always tell my students of math, the way you can understand. Now, let's look at number two, a tricky question. Root 3, open bracket 4 plus root 18 close bracket. What it simply means is this. Root 3 is multiplying everything in the bracket. So what do we do? We're going to take it 10 by 10. So root 3 times 4 will be 4 root 3. Then root 3 times plus root 18 will be, remember you can put them under one root. 3 times 18. I hope that's making sense now, right? So this is 4 root 3 plus 3 times 18. If you do the multiplication, it is 54. So at this point, what do? Look for two numbers that will are factors of 54. One of them must be a perfect square. And I can think of 9 times 6. 9 times 6 is 54. So here I have 4 root 3, square root of 9, 3 root 6. Now at this point, you cannot add them together. Why? Because this is root 3 and this is root 6. So they are not like terms, so you cannot add them. So that's where you stop the solution to the question. Now let's look at number 3. This time around is division. I have root 56 dividing root 2. Now remember, you said you can put them under one square root, which is 56 divided 2. And if you do that, you're going to have 28. Now at this point, it's easier for you to look for two numbers so that one of them is a perfect square and they are factors of 28. And your answer is 2 root 7. What about if you have number 4? Square root 16 divide 7. You can separate them so that it becomes root 16 divide root 7. Now this is a tricky one. Let's look at it. Square root 16 is 4 over square root 7. But now you cannot leave your answer in this form because when you solve SOLD, you're expected to leave your answer in rational denominators. But this is an irrational denominator. What that means is this. Your denominator should never have the SOLD or the square root when you finish solving it. So what do? How do we take away the square root on the 7? It's very easy. I have 4 over root 7. I'll multiply both the numerator and the denominator by the root 7. If you do that, you're going to have 4 root 7 divide 7 times 7 is root 49, which is 4 root 7 divide square root 49, 7. That is the answer to the question. 4 root 7 divide 7. Let's look at number 5. I have 2 divide root 5. It's the same procedure. This is an irrational denominator. So what do? We'll leave our answer in rational denominator. How do we do that? You multiply by root 5, the numerator and the denominator. So that this is 2 root 5 divide root 25. And final answer is 2 root 5 square root 25. It's 5. Now let's look at number 6. Here, you have 5 root 7 divide square root 45 times 2 root 3 divide root 21. The question actually wants us to simplify this. So what do? It's not different from what we've been solving. So I could collect like terms, multiply the, so to speak, whole number separately, and you multiply the sort separately. Okay, here 9 times 5, that's 45, and then times root 21. If you do this, you're going to have 10 times 7 times 3, 21, square root 9, 3 root 5 times root 21. So at this point, root 21 can cancel it out, and then you're left with 10 divide 3 root 5. But now I cannot leave my answer in this form. The reason why, because it's an irrational denominator. I had to leave my answer in rational denominator. So I will multiply by 3 root 5. That's what I have at the denominator. And then I will also multiply the denominator by 3 root 5. If you do that, this will be 30 root 5. Now 3 times 3, 9. You multiply the whole number separately and multiply the um, um, surd or the square roots separately. 5 times 5, and that's root 25. So this is 30 root 5. 9 times square root 25, it's 5. At this point, you can cancel out. 5 here 1, 5 here is 6. So I'm having 6 root 5 over 9. A factor can still divide. 3 here is 2, 3 here 3. So that my final answer is 2 root 5 divide 3. Very easy. Okay, now let's look at number 7. 4 divide root 5 minus 2. Now, what I'm going to do is to multiply by what we call the conjugate. Now, what do we mean by the conjugate? Now, if I start to solve this, you understand what I'm saying. It's going to be 4 multiply root 5 plus 2 over root 5 minus 2 multiply root 5 plus 2. So here it was root 5 minus 2. The conjugate of root 5 minus 2 is root 5 plus 2. What it simply means is that if there's a subtraction sign here, then it becomes a positive sign you use to multiply both the numerator and the denominator. That's the only thing that will change. And if you do that, it's easier to get an answer. 4 root 5 plus 8. And then you multiply this. Root 5 times root 5 is root 25. Root 5 times plus 2 is plus 2 root 5. Minus 2 times root 5 is minus 2 root 5. Then minus 2 times plus 2 is minus 4. This will be 4 root 5 plus 8 divide. Now look at it. This will go. This minus this will go. So I'll be left with root 25 minus 4, which is 4 root 5 plus 8 divide square root 25. It's 5 minus 4. So we could see the answer. The answer will just easily come out, and that is 4 root 5 minus plus 8 rather. And that's the answer, because if 5 should subtract 4, it's 1. So there's no point writing that. Now let's look at number 8. This will be the last example for this. Again, I'm going to multiply by the conjugates. And what is the conjugate? It is 2 root 3 minus root 5. Put them in one bracket, and then you multiply by root 3. Instead of plus, it becomes minus 2 root 5. Close bracket. And that's what you're also going to use to multiply this. You write what is there at the denominator, put in bracket because it's an expression, and then you multiply by root 3 minus 2 root 5. Okay, so what next? This times this. You see, the square root can only multiply square root, so it's going to be 2 root 9. So this is 2 root 9. Then this times this. The 2 will multiply 2. The square root will multiply square root. And that should be minus 4 root 15. The same thing here, minus root 5 times 3. It's minus root 15. And then minus root 5 times minus 2 root 5. It is plus 2 root 25. Divide. The same thing, root 3 times root 3 is root 9. Root 3 times this, it will be 2 root 15. Then plus 2 root 5 times root 3 will be plus 2 root 15. And then plus 2 root 5 times minus 2 root 5 will be minus 4 root 25. You can see this will go because minus this plus this is 0, so it's gone. So what will I be left with? Let's simplify further. This is 2 times square root 9, 3. Bracket is times, so I decide to use bracket now. Minus 4 root 15 minus root 15 plus 2 times square root of 25, it's 5. Divide square root 9, 3 minus 4 root 25. Oh, root 25, it's 5. So it's going to be times 5. So let's just do it here now. So it's gone. So let's finally simplify this. 2 times 3, 6. Minus 4 root 15 minus root 15. They're like terms, root 15, root 15. So that will give you minus 5 root 15. Again, if you're confused on how I simplify this, go watch my previous videos on simplification of numbers. And then this is plus 2 times 5, 10. 3 minus 4 times 5 is 20. Please note this is 5. Okay, I guess you can see that. And so what becomes the final answer to this question? This will be, collect like term, 6 plus 10, 16. Then you have minus 5 root 15. Then divide 3 minus 20 minus 17. That's the answer to the question. However, the answer is not neat. We can make it neat. How? We can multiply by the minus, the numerator. So that becomes minus, open a bracket for 16, minus 5 root 15, close the bracket, over 17. Here, there's no more the minus sign at the denominator. It has moved to the numerator. It's possible for you to do it that way. That's math for you. And then when you multiply, minus times this will become minus 16. Minus times this will become plus 5 root 15 minus 16 divided 7. That is the answer to the question. That's a neat solution. Thanks for watching this video. You can watch it over again to get used to solving SORD. The next video will be on equations involving SORD. And then I'll give you some questions to answer. Remember to subscribe, like the video, and share.